Good morning. So far what I see on that test through normal lines, people did pretty well. We're going to go on, start talking about position, velocity, speed.
This is going to be physics flashback.
And so yeah, it is like physics. It really is. This is really an element of physics when you think of that. And so what you have is, when you talk about position and velocity, what you have is an equation. A position equation can be written like f of x. That'd be like a position equation, and velocity relative to position is going to be f prime of x. And where we're headed later on is there's also a second derivative of position, which is called acceleration. And acceleration is going to be like f double prime of x. Now, one thing we say is instantaneous velocity tells how fast something is going at that exact instant and in which direction. So velocity has a component of direction to it, whereas speed does not. Speed has no concept of direction, no element of direction. So if there's one thing I need you to remember from this section, is that speed is the absolute value of velocity. So when I ask you the question, what do you really need to remember? I've just come out of the blue. Speed is the absolute value of velocity. Okay, that's one thing, because this is one thing that, so that's going to come up on tests and all that. So that has to be with you. So let's go ahead.
So,
yes, go ahead.
hold on. That equation looks the same. It's like the whole H thing, right?
Yeah, it's like the H thing, and this is actually the definition derivative version of that.
They just changed the letters and stuff.
So they just changed the letter. Instead of H, that's delta T.
Okay.
But otherwise, it's exactly the same.
Okay.
Is that how we found instantaneous?
Yeah.
Whatever it's called?
Yeah. And so sometimes you'll hear this referred to as the difference quotient also. But S prime of t, so if you have ds dt, if you have the position function s of t or x of t, oftentimes x of t seems to be more of a standard we use. But it could be anything. But if s of t, they're going to go ahead and probably tell you that. And so you have, if this is s of t, then this would be s prime of t, and then acceleration, which we don't talk about right here, is s double prime of t. And so there's a hierarchical relationship between them. And so let's go on to this one where it's actually working out a problem. And I'm going to put some statements up here. I'm going to go through kind of an analysis of this free response problem. And this is from an actual AP test. And so this is something that is very typical. It's called a particle motion problem. A particle moves along the x-axis, so at time t, measured in seconds, is position. And so what you're doing is you have a particle here that's moving left and right along this x-axis, and its position over time is given by this equation right here. And this is the way you see it most of the time. Sometimes you can see it moving along the y-axis. They'll change the letters. So this is a standard calculus problem. It's called particle motion. So it's just a category of problem is what it amounts to. And so we're going to kind of put together the skills in the class to do the analysis on this. And there's another thing what was the one thing I told you need to remember? Speed is absolute value of velocity. Thank you, good job. And this is another thing you need to remember here for this one going forward. It's called this. number lines are your friends. You ever thought you're going to have a number line be a friend?
No.
No.
I don't have it up yet.
Well, they are. They are. Now, we're getting to a category right now where it's possible to do these problems that we're talking about without number lines, but it's just enormously easier to categorize it. And if I have one regret in pre-calculus last year, is that we didn't do number lines more than we did. I don't think we got to chapter 2.8, which would have covered some of that. So we're going to have to. Pardon me?
I loved pre-calculus.
You like pre-calculus? Yeah, it was a good class. I appreciate you being in class last year. But this is one of the, but every time you have to, there are choices you have to make about what's taught or not. And of course, we got our year cut off because of COVID, but I don't think anything, most of the things that we essentially could have covered by then, we had a chance at least to get into. So I don't feel there are huge gaps from what we covered last year, but there are some. One thing we didn't do was number line analysis. So anyway, here's the equation for along the x-axis, and then what is the velocity? Here's the position. So what is the velocity of this? And you could probably help me with this. So v of t is equal to x prime of t, and that is going to be what? Here's x of t. V of t is x prime of t.
Oh, so you just find the
And so what is this going to be here?
3.
Okay, 3t squared
minus 12t
minus 12t plus 9. And so there we have it. And then it says, okay, and this is going to be measured in meters. So this is going to be meters per second, right? And then it says, interpret the meaning of the answer you just found. So what is this? What do we call this? Okay, this is the velocity of particle moving along the x-axis. In meters per second. Okay, and then we're asked the question here, during what time intervals is the particle moving to the left? What do you have to know? Okay, now, what you have to know about this particle motion is that when velocity is positive, the particle is moving to the right. When velocity is negative, the particle is moving to the left. Okay, so what can we do with this function here? Okay, first thing we try to do is find what we call a critical number or numbers. So find critical numbers. Now I said that we had a little gap of what we covered last year. One thing I did try to do to fill in that gap was, remember I gave you those exercises to do? It was called pre-calculus review prior to calculus. Yeah, right here, this is what we're talking about. This is exercise number 5. Find critical numbers. What is a critical number?
It's the number, oh my gosh.
Okay. What it is, critical numbers, a definition of critical number is X value that makes function equal to 0 or undefined. So that's what a critical number is. Now in the case of polynomial functions, you don't really have to worry about undefineds at all, but it's zeros that you're really trying to find. That's what you're trying to find, the zeros of this function right here. And how do you find those zeros?
Looks like we're gonna have to do some factor
Probably factoring, but even before factoring, what do you do?
before factoring.
Okay, what,
Oh, you gotta set it to 0.
before factoring, yeah, so Aaron just said it. You set the equation equal to 0, so you have 0 equals 3t squared minus 12t plus 9. And then you solve your quadratic equation. So how would we solve this one?
Add 9. Subtract 9.
Okay, now in quadratic equations, there are 5 ways we've covered of solving quadratic equations. There's factoring, which is probably your number one way you want to. There's the quadratic formula. There's graphing. And then there's square root method. And finally, there's completing the square. If I could spell complete, that would be really good. Now, as it so happens, in these first 3 methods here, and the one you want to do, if you can, is factoring.
I just did that.
In each of these 3 methods, you have one side of the equation equal 0. Okay? These other 2 you don't, but for these 3, so do you have one side of the equation equal to 0? Yes, you do. So what are the factors of this? First thing you look for is what? You look for common factors, okay? Kylie just mentioned that. So you take the 3 out, Kylie, what'd you get? T squared?
T squared minus 4 plus
4t plus 3. And so what you're looking for, and so you divide by 3, and so what that means, essentially, you get rid of that. So you get rid of the 3, essentially. So what are going to be your factors here?
T minus 3. Yeah, T minus 3 and T minus 1.
T minus 1. So usually for these particle motion ones, when you factor them, you're going to get a minus minus, okay, as your zeros, usually. And now here comes the number lines. So number line here is, we have enough time for this. So what you do is you mark your number line at the zeros. You have x equals 1, right? Or t equals 1, t equals 3. So you mark 1 and 3 on your number line, and then you say, right up above, you put v of t, and below you put x of t. And then what you do is you choose numbers on different sides in these intervals. So the first one you look for to the left here is, what's a number less than 1?
0.
0. So that's the easiest one. Plug in 0. So if you plug in 0, what do you get?
Negative 3 times.
You get negative 3 times negative 1, or positive. So you know that the function equals 0 at 1 and 3, and so you know you are less than 0, or greater than 0, excuse me, because you have a negative times a negative. So that means that x of t is actually going down during this interval. And what happens between 1 and 3? Like 2, right? If you plug in 2, you'll get a negative times a positive, which is negative. And I made a mistake here, because I said positive and I wrote the arrow the wrong way. So it goes like this. Okay, and then negative between these two, so position is going this way, and then to the right you have a positive times a positive. And so anyway, it says during what time intervals is the particle moving to the left? Well, the particle moves left during which time interval?
Between 1 and 3?
Yes, Gavin. Moves left on the interval, and what we do is on, you put -1 or 1 comma 3, left on 1 comma 3, because v of t equals x prime of t is less than 0. And so that's your answer. This is your answer right here, and your justification.
Wow.
And you can pre-justify and put, you know this is going to be your answer because v of t equals x t, even before you figure out what it is. So that's it for today, and we will leave it at that point.
The law says negative